Good morning to one and all. I am Parthivan working as an assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. So I am going to talk about the subject called electron devices, which is coming under the regulation R 2025. The subject code is EC25C01. Now I am going to talk about the unit 4. The topic is JFET. So what is JFET? Junction Field Effect Transistor. It is a three-terminal semiconductor device in which the electric field produced by the gate voltage controls the flow of current through the channel. The three terminals are there, namely gate, drain and source. Because the gate voltage increases or creates an electric field which changes with the width of the conducting channel. So unlike BJP, no significant gate current flows here. So the construction of the JFET mainly depends on the channel. Here we are depicting the N channel JFET. The main body is made of N-type material. On both sides, the channel are P regions. The P regions are connected together to form the gate terminal. The two ends of the N channel become source and drain. As I already told you, both are interchangeable. The gate and channel forms the PN junction. Normally, these PN junctions are reverse biased. Source supplies the electron to the channel. Drain collects the electron after they travel through the channel. So the gate controls the width of the conducting channel. Since gate junction is reverse biased, almost zero current flows. That is why JFET has a very high input impedance and a low power consumption. So coming on to the slide, you can see there is a condition that is called when VGS is less than 0, VDS is at some positive value. What will happen? So the gate source voltage, which is VGS, is 0. A positive voltage is applied to the drain. The electrons begin moving from source to drain. The conventional current flows from drain to source. As the drain voltage increases, the diffusion near the gate becomes wider. The conducting channel becomes narrower. Therefore, the current gradually becomes constant. The gate voltage controls the size of the diffusion region. Larger reverse bias, wider diffusion layer, narrower the channel, less is the drain current. That's what the observation from the diagram. Then coming on to the next one, that is a pinch off. We can say a pinch off is a condition that is almost near to the saturation. This is one of the important concept in the concept of JFET. As the slide shows, the increasing the VDS causes the depletion region to expand until they nearly touch, restricting the channel. Pinch off is a condition where the depletion region expands enough to nearly close the conducting channel. At this point, the drain current no longer increases significantly even if the drain voltage increases further. So the pinch off voltage, which is nothing but the drain voltage at which the pinch off occurs, is called pinch off voltage. So this is a very important aspect in the JFET. So many after pinch off, the current becomes almost constant. This constant current is the saturated current we can see. In the next, we are going to see about the drain characteristics. So the drain characteristics versus the source voltage for the different gate voltages that we have seen. There are some operating regions are there that we can say it is a ohmic region, saturation region, as well as the breakdown region. So these are the three important regions that plays the crucial role in the JFET characteristics. First of all, ohmic region. Ohmic region is a small drain voltage where the current increases linearly. The JFET behaves as if like a resistor. After that, there is a second region that is called a saturation region. In the saturation region, there is a, we can say, a point that is reached, the drain current becomes constant. This region is used for amplifiers, particularly as an amplifier, in also analog circuits. The next region is called breakdown region, where When the drain voltage becomes extremely high, the avalanche breakdown occurs. The drain current suddenly increases. The device may get permanently damaged. So we have to handle very carefully. So we have to wind up before the breakdown region. That's what an important aspect. So the transfer characteristics shows the drain current versus gate source characteristics. So initially the drain current is maximum. This maximum current is called IDSS. As the gate voltage becomes more negative, the drain current decreases. Eventually the drain current becomes zero. This voltage is called VGS off. So these are the very important essence that we can observe from the graph. So we can say the various advantages of JFET. Some of the important advantages are it has a very high input impedance, almost zero gate current flows. In high input resistance is extremely high, which is an added advantage. So low noise, particularly suitable for audio amplifiers. It is having a very low power consumption also. Since the gate current is almost zero, the power loss is very small. It has a very good thermal stability, which is a favorable feature, which is having a fast switching also. Since majority carriers only plays a crucial role, the switching speed is high compared to BJT. So disadvantages in the sense it has a lower gain, a high output resistance, and limited current capability. That we can say as a drawbacks of JFET. So these are the references that I used to have. Thanking you one and all for hearing my lecture. Once again, thank you very much.